Hello, everybody. I would like to present today how we can calibrate the volatility surface on Excel using Solver and multiple regression. With Excel, you can beautifully create a surface plot using consistent volatilities across moneyness and maturity. In order to do it, what we need first, we need some data. I got the data from Yahoo Finance. I use for that SPX index, where you have many strike prices for various maturities. You see they are normally created in this way. You have different strike prices in the column C. Then you have the bid and ask price, and this is repeated for various maturities going forward. What I did, I took the bid and ask price, added together, divided by 2, and got the middle price. I excluded for my calculation the first month. It was based on it was created, or the data was taken on the February the 12th, so I excluded April, but following for April, you can see on my screen here, I took these various prices and created the table like that using X lookup. So it was quite easy to get this data out of individual sheets or tables, because for every maturity, Yahoo Finance create a separate table. Okay, so we have, as I mentioned before, I will not use into the further calculation options premium for April maturity, but what we will use for our calculation, we will use the interest. I assumed 5% without any changes. The starting date was the 12th of April, and the price of the total return index as for SPX is end of the day 12th of April, 5,123. And I need to know how far away we are going into the future. I went up to 1 year, up to the 31st of March, which I assume it is 1 year, or 252 working days. With this information, I could calculate what this means as the part of the year. So 1 year is 1, and okay, 182 days are 74% of the year. This will be used in the further calculation. Easiest way to proceed is with the solver. Why? Because I don't need to make a lot of changes. What I need to calculate, I need to calculate theoretical calculated prices. You see here, the actual price was 11.49. My price, which I calculated, is 11.51. Then, assuming that I will explain the calculation in a moment, assuming that is the best price what I can achieve, I have to calculate the difference of these two prices, actual price and calculated price. Since positive and negative difference is difference, and I want to treat them the same, and the higher the difference, the worse this particular data is. So I take the square of that. Then all these squares are counted together, and I sum all these square differences and calculate the square root of that. So this is the number. With help of solver, I have to try to minimize, to make as low as possible in this case, in order to find the best parameter for my function. So how we proceed? First, we have to calculate theoretical price of the option premium. I use for that Black-Scholes model. It is just only entered in one formula in one cell. Normally you do this like this, for example, that you have calculated first D1, D2, ND1, ND2, and then you have the cell where you calculate the option. I put this all formula into one cell, and then I only need to enter the same information which you had to enter, which you enter normally into the option, into the Black-Scholes formula, and then you can calculate the premium. I use this formula, so you can. I will provide you with a copy of this workbook, so you can slowly digest. But it is nothing else but just Black-Scholes formula. I enter this in one cell. I have to take care that some information can only relative, the other absolute. So I have to, for example, when I calculate the logarithmus strike price, logarithmus spot price, which will be always the same. It is as it was on the April the 12th in this case. And when I divide by strike price, it is absolute will be the column, but when I move in the row, it would stay the same. But if I go down, it will be changed. So I have this formula. I now just copy and copy down. All these calculations are wrong. Why? Because what I am still missing is my volatility. I have to calculate my implied volatility. And in order to calculate volatility, what I am doing, this is my function which we can use to calculate volatility. So volatility is a function of moneyness and time. And this function requires a constant parameter E, so A, then plus B times logarithmus spot price divided by strike price, plus C times T, stands for time, plus parameter D times logarithmus spot price divided by strike price square, plus E times time square, and plus logarithmus strike price, spot price divided by strike price times T. This formula I have to enter into this cell. And what I am doing, the parameters I keep in one space, which I can now, I will need this when I am assuming my, when I use this for my solver or regression calculation. But at the moment we are speaking about solver, so I have to use this formula, which represents exactly this formula here, which we enter it here, what I'm showing. So now what I need to do, just copy to other cells, copy down. Okay, I already used the solver, and in order to show you a little bit better results, let's delete everything what we have here. So now with these parameters, the error is quite huge. It's almost 1% in this case. The volatility is just the fixed amount. I left the A parameter standing, so it still shows not as bad calculation as it could be if I didn't have the A right number. So now we have to work with the solver. With the solver, as I said, we need to try the minimum value for this cell. Solver, if you didn't install it, you go to File, Options. In the option, you have the add-ins. add-ins, Excel add-ins, and it shows you add-ins available for Excel is analysis toolpack, which can be included. You will need this for regression. And then we have the solver add-in. In my case, both are installed, so I don't need to do anything. I can go now directly to data, and then I see the solver. With the solver, I said we want to, I have to move it, but I see what I am doing. Okay, the solver already, no, it doesn't stand on this, on the right, it was, I have to take this here, and we have, okay, the changing variables are already correct. I have to it must be AC 90, 90, 90, I assume it is okay, or just to be on the safe side, I show it again. Okay, 90 to 95, and it must be, I must press minimum. I want to have this value in the cell AD58 as the smallest one, and I just press solve, and the result is done. Okay, it's finished. We have, and we see, and we have big improvement. Now the arrow in percent of option price, actual option prices is 0.19%. So it's biggest improvement. But you also see that some of these parameters in principle didn't have big impact. It was E and F parameter were calculated as 0. You can use something when you, for example, for foreign exchange options, or instead you could change the parameter E, not times, but use the difference between foreign interest and local and interest in which the currency is quoted, and then you can have the better estimation, for example, for implied volatility surface for foreign exchange situation. Okay, so this is in principle how you proceed to find the parameters. Now you are able to create the surface. How we do that is exactly, we use for this data table 2. It is one of the comments that we have in Excel. Or in the first row, I write different strike prices. I can interpolate everything, and for example, the strike price of equal to the spot price, it was never quoted, but I can calculate this theoretical or calculated volatility for this price as well, and I have the time from 1 year, 0.8 years, and so on. And this is the formula which we have to use for our created table 2. It is any formula which shows how the volatility is calculated. I took T42, so it will be just that it is 42, okay. So I will have to take spot price, strike price, and time is here. Okay, so I am going back to my, well, I have this. Just a moment, it is not right. In principle, this can be deleted, but you see that is that we recreated this again. Okay, now I go to data, what if analysis, data table, and I have to enter, I said it was 42, because this formula refers to this formula for the how we calculate volatility. So we have for strike price, and for time it was 52. Time is here. Okay. Everything is calculated. It's done. Normally, you would maybe say, okay, now I can use this for a basis to create the plot, but I don't know why. When I try to do this, I couldn't get the volatility surface chart as I wanted. What I realized, if I copy this to the fixed values, Control-C, file, no, I like my old base spatial, just values. Okay, I created here this with values, and when I remove the first cell here, now I can create easily my volatility surface. So now I go insert, there's recommended charts. Okay, I want all charts and look for the surface. Okay, I have my surface. Beautiful. I don't like this particular surface. I can go to chart design, and this is what I really want. And what I prefer, I want to switch row and column so that I have the strike prices here on this axis and time on this axis and volatility here. So you see this, I have created volatility surface. Now you can play around, make a chart title, add nice description for both strike prices and time, and so on. But in principle, it is already, the surface is created and can be used for other purposes. So this was one idea, how we create volatility surface with help of solver. The second possibility is to do this with multiple regression. I have the same function which I will use to recreate with multiple regression. I would like to calculate, estimate these parameters in this function, A, B, C, D, E, and F, which I have to cut. And in order to make this as multiple regression, what we need, I have the area where is my X variable and my Y variable. Here I have my all X variables and volatility, which is created here, is in this variable. As I already explained, you're showing this in case of when we use the solver, volatility is calculated according to the provided function. We have to calculate this as we in order to replicate this function. And how we do that, it is how I get my data from Yahoo, or more or less in this form. So you see it is I have the strike price with 4,000, and then I have various maturities. I have to change this columns to rows, and now I have all 4,000 strike prices in one column, and I have to follow with the prices which I had here in one row. I have to change this to column as well, and I have to repeat this process for every strike price in order to have this in this form. It is additional work. So I say it is easier to do with solver, but otherwise the results are the same. So when I convert this in this form, okay, I have to convert as well time, but I have the time for every strike price, time for every strike price. So it is always the same. I am repeating these values for time. Now I have the calculated price of the with the Black-Scholes model. It doesn't need to be here. Okay, it has to be somewhere, but what I really need is this. I will use this as the X area, this information in this 5 or 6 columns. As per this formula, I have the logarithm strike price, spot price divided by strike price. This is the first formula. And then I have the second, it is the time. The third is logarithmus spot price divided by strike price time, square, and then time square. And again, logarithmus strike price, spot price divided by strike price multiplied with time. It is my F. Will help to calculate my F parameter. Okay, so I am done. So now what I need to do, okay, I need to take this, my calculation, and copy down. I already did this. So what I need to do, I need to call my regression. And again, I already installed this, as I shown at the beginning. So I have this in the data, and then I have my data analysis, and I look for regression. Where is my regression? I have my regression. Okay, so now with the regression, I have the input range Y. So is where I calculate my volatility. If you start from the beginning, the values which you will see, they are not calculated properly because your parameters are not calculated properly. But since I did this couple of times, I have now already volatility calculated, but it is the end how it will be done. Okay, the next is I have to take my X value. So it is XS. Okay. Did I started to show the levels or didn't I? I have forgotten. Now it is without levels, but constant is 0. No, constant is my first parameter, A, so it's not 0. Everything is fine. Okay, I have to find the output range, which is empty. So I have to go, how I go there. And now this is not correct. I need empty space here, so I go down and press OK. And you see we have, and parameters are calculated already the same as we had before, but you see in multiple regression, when we use solver, we receive for E and F parameters value 0. Here we have 8 times 10 to minus 17. It is in principle 0. Now the process is further, you do the same. You use this to calculate your table with the data data table, and then you have your volatilities, which you can then use as I have to repeat again what I did before. I copied the information again as the fixed values in order to remove the cell, because if I remove them here, everything is gone. So I can't do this way. I have to copy and then use this as the basis to create volatility surveys. Okay, this is all. I hope you like it and you learned something. Thank you very much. Bye.